Hey everyone and welcome back. Now in today's video we'll be discussing about the basics of Consul at a very high level overview. Now Consul is one of the very popular tools and in fact a lot of organizations are now implementing it within their production environments. Now, before we go ahead and look into the details about Consul, let's take a step back and look into the challenges that organization used to face earlier, and later we'll look into how Consul can help in those challenges. So now let's quickly look into the architecture of a monolithic application. Now in a monolithic based approach, there is a single application that gets deployed, and this single application in turn has multiple subcomponents. So let's consider that you have an application here. So we'll be taking an example of Udemy application since everyone is familiar with it. So let's assume that Udemy application is based on a monolithic based architecture. So you have a single application, and within the single application you have various subsystems related to payment, related to ratings, related to messaging, and related to QA. However, all of them together forms a single application together. So if you want it to be up and running, then you deploy the complete application package to the server and user can log in to the server and start to use it. Now, there are various challenges that one can face with the monolithic based approach. One among them is related to bug. So if there is a bug in any of the subcomponents within the entire application, then if you want to fix it, you'll have to redeploy the entire application here. So for example, in this application, there is a bug under the payment system and this entire application is already deployed in the server. So now if you want to fix it, you will have to fix the bug in the payment system and again deploy the entire application to the server yet again. So let's quickly look into some of the disadvantages of monolithic based architecture. First one is that the application and the code base size increases over time and it becomes difficult to manage. So when you have a single code base associated with payments, rating, QA and messaging, it really becomes very difficult to manage in a longer time. Second challenge here is that as the code base size increases, it also takes more amount of time both to deploy the application as well as start the application. So this is also a disadvantage here. Second is that whole application needs to be deployed as a package together even when there is a smaller change that you want to add. Third is that even if a single part of an application is receiving huge traffic, we need to go ahead and deploy the entire application into the new servers that you're adding as part of the scalability. So for example, let's assume that users are using the question and answer system very extensively within the Udemy application. And due to that, the entire application that is deployed in the server and the server is slowing down. So since the entire application is deployed in the server, even if a load is coming up into one of the subcomponents, if you decide to go ahead and add more servers to handle the load, in the additional servers, again, you will have to deploy the entire application here. There is no way in which you can go ahead and deploy only the QA system which is getting the higher load in a monolithic based architecture. And fourth one, as we have already discussed, which is single bug can affect the whole system. And these are some of the reasons why organizations are moving from a monolithic based approach to a microservice based architecture. So in a microservice based architecture, the complete application is divided into set of individual services. So now instead of deploying the complete application together, now you divide it into a payment system, messaging system, rating system and QA system. So these are individual services all together and each service can independently deployed as well as scale. So here you have deployed payment in server 1, messaging in server 2, rating in server 3 and QA in server 4. So let's assume that there is a high amount of load in the QA system. So now what you can do is you can leave the other systems intact. You can increase the servers associated with the QA system. So you can add a auto scaling here and a similar approach. So a microservice based architecture allows us to have a lot of flexibility here. However, it also comes with its own set of challenges. And major of these challenges can be solved with the help of Consul. So a console is a service mesh solution providing a full featured control plane with service discovery, configuration and also segmentation functionality. So we'll be discussing in great detail about each one of these in the later part of the course, but at a high level overview, just note that there are four primary features of console. First major one is service discovery. A lot of organizations use console primarily because of the service discovery functionality. Second is health checking. Third is KV store. Fourth is secure service communication. So at a high level overview, let's quickly look into each one of these. So now we have already discussed that in a microservice based architecture, each service can be deployed in a different servers. So let's assume that a payment system is deployed in server A and the messaging system is deployed in server B. So if a payment wants to communicate with a messaging system, how will it communicate in this approach of microservice? So when you discuss about a monolithic based approach, if a payments wants to communicate with messaging system, it's just a functional call away. Primarily because all of these are within a single application. So it's very easy and very fast as well. However, that is not the case in microservices. So in microservices, service discovery is one of the very major challenge that console solves in a great manner. So what console does, console maintains a central set of registry which has the IP address and the port information of all of the services. So assuming that the payment wants to communicate with messaging system, payment can go ahead and send a request to the console. Console will immediately give the IP address and the port number associated with the messaging service. So this becomes much more easier. The second feature here is health check. So console with the help of health check functionality will only keep the healthy instances data within its database. So let's assume that there are two servers where the messaging system is implemented. First one is 172.31.0.10 and 172.31.0.12. Due to some reason, the second server where the messaging system is deployed is not working. So console will not go ahead and persist the IP address of the failed server into its registry. So for example, if a payment system is querying the console to get the latest set of IP address for messaging system, console will not provide the IP address of the server where the application is not functioning well. It will only provide the IP of the server where the messaging system is working well. So that can be implemented with the feature of health check. Third feature is the key value store. So key value store is generally used for storing the service configuration and other metadata. So let's say that you have 20 servers of messaging system and 15 servers of payment system, and you're adding the configuration associated with the application hard coded into the server itself. So let's assume that after few days you want to modify some parameter in the configuration file of messaging system. So now what you have to do, you will have to log into 20 servers, modify the application configuration in each of the 20 server and maybe restart the application. So this is a cumbersome process. So with the help of the KB store, this can be automated in a much more easier way. So let's do one thing. Let's have a quick demo, post which we'll be discussing things in more detail. So currently I am within the console GUI, and this is how the console really looks like. So under the services, you will see that there are multiple services that are available. Similar to what we were discussing, you have payment, messaging, QA and rating. So here you have messaging, payments, QA and rating. So this is a microservice based architecture where each of these services can lie on a different server altogether. And if you query this service, so let's say if I want to see on which IP address the messaging service is running and also what is the port associated with it. So you can easily find it from console. So it says that it is running on 159.65.141.160 and it is running on port 8081. So it is very easy for us to find the exact server where our messaging service is running currently. So now if a payment system wants to find a messaging system, no issues. All it has to do, it has to contact console. Console will give the latest IP address and the port where the messaging system is running. So this is the first part. Second feature of health check. So what that basically means is that if the application of messaging system is not working due to some reason, so console will not return back the applications that are not functioning well. So that is the health check. Third is related to the key value store, where you can go ahead and store the configuration centrally. So let's say that you have a configuration of whitelisted IPs where you have a set of IP addresses here, and these configuration are being referred by 10 web servers that are running in your organization. So tomorrow, let's assume that you are adding few more IP address here. Let's say 192.168.0.5. You have added one more IP address here. So now, if you are storing it at a console level, then with the help of certain functionality, console will ensure that all of the 10 web servers that are running, they use this updated configurations. So the entire process can be automated. All you have to do is you have to modify the application here, do a save, and all of the web servers that are referencing to this specific configuration will get the updated contents. You do not really have to worry about anything. And the fourth feature, which is the secure service communication, is where the sidecar proxies are used to automatically establish a TLS connection for both inbound and outbound. So what happens here is there are two service, dashboard and counting, and both wants to communicate with each other in a secure way. So if it wants to communicate in a secure way, either you modify the service and add the related configurations, or you can make use of a secure service communication where there is an additional sidecar proxies that are used, and this sidecar proxies ensures that the communication between both of them is end-to-end encrypted. Now this is a very interesting feature and we'll be discussing in great detail about this in the upcoming videos. So these are the four primary features of console, and in the upcoming section we'll be discussing about these four features in great detail, along with various additional aspects of console related to high availability, fault tolerance, console enterprise, and so on. So with this we'll conclude today's video, and I look forward to see you in the next video.